Okay, in the last video we talked about a couple different ways of interpreting probabilities, both of which are scientific, empirical, and largely entirely based on the notion of frequencies. So the interpretations of probabilities that we've looked at so far take probabilities to be certain frequencies of measured events over a certain number of occurrences in which those events could happen. So the frequency of a coin flipping heads over, say, 100 tests is the probability that that particular coin gives heads. Now, we saw that there were a couple problems with this version of probability. One of those problems was that you can't measure the probability of a single event or a non-repeatable occurrence. And this is a problem because we often assign probabilities, or at least use probabilistic thinking with regards to one-off events. And if we want to say that the one-off event that I'm lost, but I'll probably make it home if I turn right now, that there's no frequency to the probability of my turning right, but there might still be a certain kind of probability that we want to assign to that sort of decision. And if we do, then we need to interpret the meaning of probability, right? What is a probability? Slightly differently. And so what we do is we look at, or we interpret probabilities as subjective things. And this is the subjectivist. The subjectivist theory of probability doesn't take a probability to be some theoretical equation, whether observed or not, that's supposed to tell us that the frequency of a certain event. Rather, the subjectivist interpretation of the theory of probability tells us that a probability is a degree of belief. And in this manner of speaking, a probability is just how much you believe it, right? So if I'm going to, so in the last video I used the example of minting a new coin. I work for the US Treasury, I mint a new coin, and I say, okay, I'm going to start flipping this coin, and I want to know before I flip it, what's the probability that I flip heads? Now, for the frequentist, this is an impossible question because there's not yet a frequency to measure the number of heads that this particular coin that's just been minted will be flipped. However, I'm not a frequentist in this example. I'm not a frequentist interpreter of the meaning of probabilities. Rather, I'm a subjectivist. I believe that probabilities are just degrees of belief. And I believe, given my experience with all other coins in the past, that this newly minted coin will work just like the rest of those. And so I say that the probability of the coins flipping heads is 1/2, right? That there's a 0.5 probability that the coin lands heads. And I know this based on my degree of belief. I have a very strong degree of belief on the basis of all of my past experiences with coins. And so even though this is a one-off event, given my sort of current epistemic, which means state of knowledge, my current epistemic state, the mental stuff going on in me, I am pretty certain that the coin has a 50-50 chance to flip heads. I don't need to run any tests. I can just look at it and know that one's probably going to flip heads about half the time. And so I just use the word epistemic. Sometimes these subjectivist theories of probability are called epistemic as opposed to logical. The frequentist view of probability would be a logical view as it's based in mathematical or scientific axioms or assumptions, I suppose. And this theory of probability is epistemic because it's all internal to us. It's how much are we, how much conviction do we have in the occurrence of an event. And I have, say, conviction up to 0.5 probability that the coin that I've just minted will flip heads as soon as I do it for the first time. Now, there are some upshots to this view of probability, which again, we can measure the probability of one-off events, non-repeatable events, events that haven't occurred yet. And also it captures some of our intuitions about what probabilities are. Just in the way that we use the word probability in our everyday life, that the word probability is applied to many things that are not frequencies. Like, it will probably rain tomorrow, right? There's not a frequency of tomorrows in which it rains or it doesn't, unless we somehow have this perspective from which we can roll the world back and then roll it forward, right, 100,000 times and see how many of those times it rains tomorrow. No, we don't have that power. And tomorrow is not a repeatable event, but we still say that it's probably going to rain tomorrow. And the subjectivist theory of probability captures this particular intuition, or this way of speaking about probabilities, because it's a degree of belief that determines whether or not we're going to say that it's probable that it rains tomorrow or not. But as with the frequentist view, there are problems with the subjectivist view as well, that there's some costs, which is that, first off, probabilities rely upon knowledge, that two people who have very different kinds or degrees or levels, whatever it is, of knowledge, who just are epistemically diverse, right, could come to valid conclusions about the probability of some event, like that it's going to rain tomorrow, and both be right even though both of their probabilities are different. And this is because the justification for a subjectivist theory of probability is something that's internal. It's knowledge. And so we're not worried about the actual case of the world, right? Whether or not it will rain tomorrow, to determine our degree of belief as to what the probability of its raining tomorrow will be. Rather, in order to determine the probability on the basis of a degree of belief of whether or not it will rain tomorrow, what we need to do is look internally and say, given what I know about how skies look and what my phone says the weather is going to be like, and the weird tingling I get up my spine before it rains, right? That these are the kinds of things that are required to found or justify a degree of belief. But those sort of epistemic states can, again, be very, very diverse amongst individuals. And even though they both assign different degrees of belief, just so long as those degrees of belief are properly related to their internal epistemic state, right, that there's a justifying relation, then they're right, even if the probabilities are different. And this is going to make scientists and statisticians and basically anybody who's interested in hard and fast numbers that are mathematically provable universally, it's going to make them uncomfortable, right? They're going to start itching in their shoes at this interpretation. But again, the interpretation does capture the way in which we talk about probabilities, like it's probably going to rain tomorrow, or I'll probably be fine if I go left or right, given that I'm lost in the woods, or this coin will probably flip heads about half the time, even though it's never flipped before. So there are ways that philosophers try to mitigate the costs of this particular form or interpretation of probabilities. First, they often extrapolate the probability theory, the interpretation of probability, from just a particular individual's degree of belief to a population's degree of belief. And so we get rid of the problem of diversity in epistemic justification for degrees of belief or probabilities by saying that the average or the mean of this population's degree of belief that it's going to rain tomorrow, say a population that has iPhones or any sort of phone with a weather app. Every single person does, and every single person checks their phone in the morning, and every single person sees that the forecast for tomorrow says rain, and so the whole population determines that it's probably going to rain tomorrow. Now, there might be some deviance here and there, right? That there might be some weather app climate skeptics, right? These people who look at their phone and see that the forecast says it's going to rain tomorrow, and they think to themselves, my phone doesn't know it's going to rain. I think it's going to be sunny, right? And these people are not in the majority of the population, and so you might still say that it's probably going to rain tomorrow because the whole population says so. Now, again, you get some tyranny of the masses kinds of problems here, so you can't escape it. But this is one way of mitigating the costs. Another way of mitigating the costs is by trying to rationalize belief, is to say that a belief can only justify or ground a determination of a probability just so long as that belief or degree of belief is structured rationally. Now, this is abstract, it's ambiguous, and it's one of the problems for subjectivist interpreters of a probability, because what they must do is they have to not only set out a set of axioms to give a series of laws that characterizes and determines what counts as rational, but they also have to be able to practically take that set of laws, definitions, rules, axioms, or whatever, and apply them to real degrees of belief in real time in the real world. Now, both activities are challenging. I'd say it's probably much harder to go from a set of definitions to application of those definitions in the real world, especially with regard to like belief and mental stuff. It's tough business, but philosophers try to do it, and we'll try to do it too. In fact, we will do it. So, in the next set of videos, what we're going to be doing is looking at some very basic rules, equations, and laws of probability. And these rules and laws of probability apply both to the frequentist and to the subjectivist theories of probability, insofar as the subjectivist accepts rational degrees of belief, which all of them do, most all of them. Now, we're going to be formalizing and axiomatizing our probability theory, but nowhere near as in-depth as we did for our deductive logic section. And before we do that, we're going to be talking a little bit about some problems that come up when thinking probabilistically. That's the next video. On the docket is just sort of general problems for thinking probabilistically, and then how to justify or think of or axiomatize our probabilistic thinking, either in terms of rational degrees of belief or observed frequencies. It's going to be the same both ways. It's just how we want to interpret it downstream. What these equations are telling us about the world. Are they telling us that there's a rational degree of belief that gives a probability from these equations, or rather is this probability the derivation of some sort of frequency? So anyways, as I said, we'll get to that all in the next 3 or 4 videos.